measure. So examples for discrete data, for example, patients, number of patients, number of tumors, number of treatment fractions. Example for continuous data, LET, dose average, LET, biological dose, or blood pressures. I put this guy here, it's me. This guy here, me, I am always working with quantitative continuous data, which it always LET and does average, LET, biological dose. Now, I do have some qualitative data, but I'm always in the quantitative data, continuous quantitative data. And I think it is very important for us to understand our data so we can know how we analyze our experiment or data, and we can predict the result or the behavior of our data. Also, we can defend our thesis or after creating our hypothesis in our research. So now, if we understand what data we have, we can measure this data. The way we measure this data in two different ways. One is measure the central tendency, which means we are seeing how the data behaving. What is high, what is low, what is important, what is not important. And to do this measure of the central tendency, we have to know three main things. I think they are easy, but need to be understood, and we will review it quickly. The mean, the median, and the mode. Those three allow me to know what my data is doing. Now, the other way is to measure the spread of our data, how my data is behaving, how my data is going to be, or how it has been. To do this, we have to do we have to acknowledge three things. The range, something we call IQR, interval quarter rate or something, and the standard deviation. This is the three things. So mean, median, mode allow me to measure the central tendency. Range, IQR, standard deviation allow me to measure the data spread. Go.
What is IQR?
Interval quarter rate. We will go in front. Okay. We will come. And it is very amazing things. Okay. Yeah, because of this IQR, we can find out something called the B value, but we will come to it. Probability value. We will come to B. Yes. Oh. Disaster. So what happens to my video now? Wait, I need to continue recording. How can I need to stop sharing, go again? Yeah. Disaster. Yeah. Oh, I am online. Am I recording now? Yes. Oh, still recording. So I just keep going. Yes. Okay, so we are back. Nice. So yeah, again, what happened? So for us to understand how we measure our dot, another question.
She asked me about what this group work is.
statistic.
Yeah, I know. So the whole thing we're doing now. She didn't get it. She didn't know it.
Oh, okay. But you understand, we will talk about this later, but now statistic, you
Yeah,
understand
yeah.
what I am saying. Okay, good. So, okay, let's continue. So we understand this two ways of measure data we use in our research. I don't think in I think in every research in the world. They have to do this one, no matter what is the topic. Any research has some data uh, has to follow this two way. And to continue, we'll start with the first one. What is the mean? What is the median? What is the mode? Now, this, why we want to know the mean and the median and the mode, it's allow me to describe the center of the data. Now, what is mean? Mean basically is the sum up of all the value in data set divided by the number of the data value. And we have it in two ways. We have sample and population. It's the same. They just, the mu here and the x looks different here. However, the most important things, we are calculating the mean to know the average of my data set. And this average allow me to find out something we call the variance. Now the variance is important because the square root of this variance is the standard deviation. Does that make sense? Now standard deviation we use a lot. We will come in soon, yeah, we will go and talk about it. But the mean is important because it is the only way for me to find out the standard deviation. But I cannot find out the standard deviation by itself. I have to find the mean, and from the mean, I have to find the variance, and then from the variance, I can find the standard deviation. But nowadays, we don't do this. Technology does this for us. We just put it in Excel, Excel do everything, or any other software. However, I think it is good for us to understand. We usually don't do this. You can just Google it, or software Excel, or whatever. So this is the mean. And then there is something called the median. The median is usually the middle value of arranged data. So if I have, for example, five set data, can I write example here? No.
Yeah.
Can I? How can I write something?
What can I read?
I don't think I can. Anyway, so for example, but I can write something here. This is can wait for me.
This whiteboard.
Yeah, this is can wait.
Oh, okay. Yeah.
So we are here to understand. So why wasting the time? So let's say, for example, so good. So I can write here. Yeah.
You found now?
Yeah. So let's say, for example, I have this data set. I go 2, 1, 4, 2, 5. Say, for example, I have this data. Can you see?
Yeah.
2, 1, 4, 2, 5.
Yeah.
Now I want to find the
Medium.
mean first.
Mean.
So what is the mean? Sum all of this up.
Yeah.
And go and divide by the number.
Huh?
Get everything and divide by the number of
Yes.
40.
So how much? Let's take. This is 6. No.
No.
3, 7,
4. 4 to
14.
14.
Ah, 違う違う。
14.
Yeah.
No, no, no. Yeah,
So that my mean it will be equal 14 divided by 1, 2, 3, 4, 5.
5.
14 divided by 5. 2.
8.
I trust you. Are you good? I'm not good in calculating. So 2.8.
Yeah.
This is my mean.
Yeah.
Now my median.
Should be 2.4.
2.4, I trust you. We have calculation.
2.8.
Who am I supposed to trust? I trust the calculator.
2.8.
Disaster. Anyway, so we agree to win 8. Daiju. This is mean.
Yes.
Yes.
Medium.
Medium is 2.
How did you decide medium is 2?
5 plus 1 divided by 2 is
1, 2,
3.
3, 4,
1, 2, 2,
1, 2, 3, 4, 5.
4, 5.
Yes.
So you're trying to say, I have 1, 2, 3, 4, 5. So 5 plus 1 divided by 2.
Yeah.
5 plus 1 divided by 2 is equal to 6 divided by 2?
3.
3. So my medium is 3. Okay? So this is the medium. What is the medium here?
It's 2.
Yeah, it should be 2.
How come the median is a 3? I have
That's
5.
different than median.
Yes.
The
Your
median
median
value
standard is a difference.
Now let's calculate the median.
I think that equation says the median is the third value after arranging that bracket in order.
I think the median is
Yes.
Median is 2.
It's 2.
Yes.
True.
Not
Not
the.
3.
how did you calculate?
Plus
That
calculate.
equation means that the third value is in that bracket is the median.
The n value.
Yeah, that equation says that the third value is supposed to be the median, and we're supposed to rearrange that those values in order.
We have to rearrange this value in
Yeah.
order.
Yeah.
Yes, that's the first things we do. We have to, that's correct, Eddie. First things we do, before we go to this equation, before we jump to this. Now the equation is good. The equation is not wrong. Yes? But the equation says to us that the number of those elements plus 1 divided by 2 can be the median. Which means this equation is saying to me, in my set, the medium will be the value in the middle. Yeah? But before I find out the value in the middle, I have to do what Eddie said. Arrange my data first in order. So I will go first 1, 2, another 2, 4, 5. I arrange my data first. And then after arranging my data, I find the median, which this equation telling me it is the value in the middle. So 1, 2, 2, 4, 5. What is the median?
2.
Because it's in the middle. What do you say? It's 2 in the middle.
Perfect.
So go, yeah? Now, what happened? This is 1, 2, 3, 4, 5. We have odd number. What happens if we have even number? What happens if I have 1, 2, 2, 4, 5, 3? No, 6. Now I have 1, 2, 3, 1, 2, 3, 4, 5, 6. Where is the middle number?
2.5.
No. Where is the middle number for this one?
3.
Okay, so
我说的是中数是不一样的。
so I tell you what is I tell you. You don't need to remember. I tell you. And whenever we have odd, it is always the middle value. When we have even set, it will be the average, the mean of the two middle value. So it will be, for example, 2 plus 4 is 6 divided by 2 is 3. So it's 3. You understand?
Three.
Now I have,
Divide by 2.
yes, 2 plus, this is the, we take the median of the middle of the two volume. So it's got the median. What is the median? This one. How we calculate the median, yeah? So it will be 2 plus 4 divided by the number of them, 1, 2. 6. 2 plus 4 is 6 divided by 2 is equal to 3. You understand? It's not too hard. Maybe I explain again. Maybe I did wrong. Okay. So, easy one.
Your
Find the,
data is 1, 2, 2 or 1, 2, 3
this one?
for your data.
This one?
Yeah.
1, 2, 2.
Oh, oh yeah, it's okay.
Maybe, oh, maybe I did a mistake.
Yeah.
Okay. So 1, 2. So first one is the easiest one. Average.
Okay.
Sum up all of them divided by the number. Yeah? We get average. 8 points. Whatever you say. This is first one. Easy. Now second one, we want median. Median for us to find, we have to arrange our data. And then after arranging our data, if the number of all the elements in data is add number 1, 2, 3, 4, 5, so the median is the one in the middle. Easy. Now, if the data is even 1, 2, 3, 4, 5, 6. Now, if I look at the middle, there is 2 volume. So for me to decide which one is the median, I have to do the mean for this 2 volume. يجيبوا. So go listen, eh? That's it. Easy.
Yes.
Yes.
Now, the last thing is called the mood. Tell me. Oh, I have to put this down. Now, the last thing is called the mood. What is the mood? It's the most repetitive number. For example, in my example, there is number 2, because I repeat number 2 many times. So the most repetitive number is what we call it? The mood. Okay, now this is the basics, easiest one. Wakarimashita, wakarimasen, tani-san. Good? Good. Now next is how we measure the spread of the data. First, we measure, this is the 3 things to measure the tendency of data. Now how we measure the spread of our data. To do this, first, we need to know the range of this data. Now, the range of this data is easy. It is the distance between the largest and the smallest value, which means the range is equal to the maximum value minus the minimum value. This is too easy. Now, the smart, wonderful interquarter range, IQR, can measure the 50% of this data. And how we can do this, how we can do IQR, is to first we need to find our Q2. My Q2 is the median And then from there, I can divide lower and upper half. Okay, let me show you here. You understand now? I just want to show you to make sure you understand. Because I mean, what I'm trying to say here is that, that is our amazing example. So the IQR, it's a way to divide our data. Okay? This is disaster slide. I need to go back one slide. So you can see the
Yeah.
no, you can see the
Write
example.
it somewhere else.
Anyway, so the IQR, if it's add number, it is my Q2. Q2 is my median. This is Q2.
Yes.
Okay?
Okay.
And then we have the lower part, Q1. The upper half, Q3. Jubu. If it's even number, it will my Q2 will be the mode, which will be the mean for this two, which we say it's a 3. And then this 2, which the value is 3, is my Q2. And also I can divide upper half, I can divide lower half. Easy, yeah? That's the IQR. So I'm playing with the range now.
Sorry, the Q1 including all below the Q2 number?
Yes.
Oh.
So not below, because number is value is different. But what means lower part, higher part, or lower half and higher half. We divided to the lower half and the higher half, according to my maximum too. But anyway, so this is my IQR. Now the magic one, the amazing one, is called standard deviation. Now what does standard deviation do? Is trying to tell me the probability of how the data are spreading in my curve. So I have certain kind of area, and I want to know how my data behave in this area. This area, I have it. And my data will always be in this area, inside here. They will be distributed here. But how can I know how they are distributed? Is by finding the standard deviation. Now, do you remember how we can find the standard deviation? It's easy. You find the mean. Because you find the mean, you can find something we call the variance. You take the square root of this variance as the standard deviation. So, and then we have two different signs, one for the sample, one of the population. The sample is called S, the population is called sigma. But they are the same, nothing different. The only difference is the type of data we have. Anyway, so in our standard deviation, we have this area. This area is divided. We divide it to, for example, one standard deviation away from 0. Now this 0, it's technically it is my mean. But we put the value, my mean is here. We start from my mean. How far I am from my mean? Am I in the higher part or I am in the lower part? The mean is in the middle, higher part, lower part. This here is the mean. Not, but The lower part, how far away from the mean, how close I am from the mean. If I cover this area, which 34.1% in the right, so I am one standard deviation away from my mean in the right side. If I cover this area, 34.1% in the left, I am one standard deviation away from the left side. So 34.1 plus 34.1, this is always mentioned as one standard deviation away. If I add more, this area and this area, I will become two standard deviation away. Daijubu. So now I will move to something more interested to us. Because those things I just said, XL will do it. We don't do it. It's just for us to understand. Technology will do. But for graphing this data, for us to have graph, to absorb, to see the data, we also, remember, we have qualitative one and we have quantitative one. So for the qualitative one, we have certain kind of way of graphing. Now there are too many ways. Those are not the only ways, but I just pick up this for random way. But it depends on what type of data we have, we can decide our graph. For example, I cannot decide a box plot graph for qualitative data. I mean, I can have it as an answer nowadays by technology, but it's not good enough. Qualitative data, you want to have charts. Either pie chart or bar chart will be good options. But for quantitative data, we need to have another approach. And I will be showing you or talking about what we call the histogram and box plot. Now, my histogram, usually, if I have a data set and I want to put it in a histogram, I have to divide my data set to as many value as I can, as many parts as I can. It's up to me. No one can control me. But usually people do divide it into 5 parts, or let's say XL divided, or software normals, they divide it to 5 part technology. You must have first a minimum value, and this minimum value has to be less than the data set minimum value. For example, in my histogram here, I have -3. So I have to have less than this. My first data set has to be less. And then I divide it to 5 parts. Let's say, for example, from -3 to -2. This is my first part. So I will divide -3 is my A. X is somewhere between -3 and -2, which should be. Then I divide again another set, another part. I have to start with -2. I have to start with my B. From my B to my C. And then I keep dividing. Usually we divide 5 times. The most important part is that this jump from here to here has to be always the same value. If it's, for example, this we jump is -1. So my jump is 1. I have always to jump 1, 1, 1. If I jump half, I must jump half in all the parts. And how can we read it? Is easy. We can read, this is how my data is distributed. First is low, then it starts to increase, and rapidly increase, it reach its maximum. After reaching the maximum, it become lower again and fell down slowly until reach the minimum. The loss value has to be bigger than the value in my data set. The other bar graph, which we call it the box plot, this one here. How can we read this one? We use this one too much in our research and department for overall survivor and for local control, and we use it too much. How can we read it? It's too easy. In histogram, we divide those to 5 groups, and we decide these 5 groups according to what we want. It's okay. In this box plot, we don't divide to 5 groups. We divide to minimum, maximum, and my Q2 is the median, my Q1 is the lower part, and my Q3, the upper part. Now, in this graph, as you can see, we have my lower extreme value is here, my minimum. And I have my upper extreme value, it's here, my maximum. I need first to find my median, my Q2. If I find my Q2, it's going to be somewhere here. Then I have my upper part, higher part, and then I have my lower part. This value here, this line here, is the median of my upper part. This value here is the median of my lower part. Wakarimashita. And the lower to the upper is my whole range. Everything comes together now. My whole range. So this box plot can show me my whole range from minimum to maximum. This is my whole range. Mean, I need to divide it to 3 quarters. Median. First, I need to find my median. As soon as I find my median, I can divide the data set to upper and lower. If I find the upper part, I define the upper part as this part. The median of my upper part is this line. Divide the lower part as this part. The median of my lower part is this one. This is the median for whole data. From this range to last range. And this point is just say this is out of range. I move.
Sorry, I have a question.
Your
Your array board is not standard errors. Your array board.
This one.
Oh,
No.
no.
She said whisker or something. Whisker. Yeah. The bar, upper and
This one.
lower.
Yeah.
Yeah.
Why the up and down arrow bar is different?
Why this one is long? Why this one is short?
It's not the
Amazing question.
standard
Yeah,
arrow.
you don't have to have a standard, because this is my whole range. First, your question is an amazing question. Thank you. This is good to mention. This is my whole range. This is my maximum value, all the way to my minimum value. Okay.
So the lowest is the lowest value,
Yes.
and the higher
Is the
highest
maximum
is
value.
the max value.
Yeah.
Oh.
But so now, for me in my data set, I will need first to find the median. If I find the median, I can divide my values to upper part and lower part.
But if the highest is the max value, the lower is the meanest value. Why have the value out of the range?
I tell you now, because now when I divide upper part, I divide all this part from here all the way to my range. This is my upper part. When I divide from here all the way to my range, this is the range of my lower part. Yes, you understand? Now, why I decide this value? Because this is the medium only for the lower part. And the value of this median for the lower part is, this is how far it is from the lower value. وكريماشتا or I go there? Okay.
I don't understand. Can you
Okay.
give me some numbers for
Yeah, I
example?
show you, no problems. It's all good. See. But this is very smart question, to be honest.
Because the data distribution, if you give the normal distribution, it's the same, upper and lower. If you have a wrong distribution, the upper will be short than the lower.
See with number. See with number. Number is good.
Okay.
Let's have set. Let's say 2, 1, 4, 2 again, and 3. This is my set. Okay? I'm just gonna do things randomly, yeah? And quickly. So I want my first. I wanna read this part. So I have to find my Q1.
Yeah. Q2.
Q2. That's right. So I have to find my Q2.
Yes.
What is my Q2?
2.
My Q2.
2.
Why you decided it's 2?
1, 2, 2, 3, 4.
Median.
Is the median. Yes.
So I have first. I have to arrange.
Yes.
Yeah.
Now the number are low, so you can know. But your data set, the number is not low. Make
Okay.
sure you arrange. So first I have to arrange 1, 2, 2, 3, 4. I see 1, 2, 3, 4, 5. So it's odd number.
Yes.
So it's the value in the middle.
Yes.
It is 2.
Oh.
If it's even number, I have to take the average of these two values. But now it's odd number, it is 2. Okay? So 2. So this value here in the middle of my, this is Q2.
Yes.
So it will be somewhere in my graph, for example, like this, has to be 2. Yes?
Yes.
Now, when I divide my Q2, this allow me to have lower part, upper part. My minimum value is 1,
Yeah.
is here. This is 1, is here.
Oh.
My maximum value is 4, is here. This is 4.
Oh.
Yes?
Yes.
This is my whole range. This allow me to have Q1 lower part, Q2,
Q3.
Q3 upper part. So good, yeah? Now, where is my Q1 in the graph?
1.5.
It starts from here. This is my Q1. Where is my Q3? Is start from here. Now, the distribution, this Q1 and Q3, this line, they are actually the mean of the lower part and not the mean, the median. It is the median of the lower part and the median of the upper part.
So 3 quarters.
So Q1 is 1.5, right?
The median of this,
Oh.
how can I have the median of this?
Is me?
Because they are even number I have to find that it's the mean. So it's gonna be 1 plus 2 divided by 2. So how much is this?
1.5.
1.5. So my Q1 will be 1.5. My Q3 will be 3 plus 4 divided by 2. How much is this? 2.5.
3.5.
3.5. So this one will be 3.5. Now your question is why this one is longer than this one? The answer is this longer because this is show you how far is your median. This is median. How far is the median of quarter one away from your minimum value? And this from here to here, how far is the median of quarter three away from the maximum value? So if the median, the quarter median one is less away, too close to the one, it will be like this, closer.
Yeah.
You understand?
Yes, I
So-
understand.
So this is why we sometimes have different, because this is my range, minimum to maximum. How far is my median to quarter one from my lower part, and how far it is from the upper part? تعجبوا. Psycho, amazing.
Another question.
Yeah.
Why have the point out of your range?
This is just to say this is out of range.
Yeah, why? Because
That's later when we find, for example, for other probability. So this usually it must be inside my normal distribution, inside the data set. Any value, this is outside the data value. I will show you now. So this dot, let's go to the standard deviation. Yeah. So we are here. Yeah. So when we convert this to box plot, minimum range, maximum range, minimum 0, maximum 3. Okay. Now the dot is telling me this value is not here, not in this area. It's here, or here, or here, or somewhere here. So this is my whole range. The dot, it's a value out of range. If you see the dot inside, it means this value inside the range.
So your mean is exclude the number to calculate the median.
Yes. But for this dot, this is just value. If this dot appear here, so this value is between here, inside. So it means it's somewhere here, inside. If it is somewhere away, it means it's out of my range. So it will be somewhere here, or here, or here. It's not inside.
So my question is next. You calculated at first you calculated the median, right?
Yes.
The median is
I
based
calculate
based on
Q.
in normal date.
Yes.
Include this point or exclude the point out of your.
I don't know. This is a different points. It depends this value. So this point is random value. Later you choose. For example, you are more interested in the example we did. You are interested in value number 1.221. So this is the dot, is value number 1.221. It will appear somewhere. わかりました? or no?
I don't understand.
Okay, let
for
me go.
example, you in your number have some number
So you know this one, yeah?
years.
Here we are all good, yeah? But we have dot here.
Yeah.
So this dot, what is this dot? I say this is volume, random volume. Okay?
So my what I said is your mean just the Q2 is based include this point or not include.
This point is for you to decide later, the volume. So for example, maybe I am interested in volume, now I have this all volume. I am interested in volume 1.112. 1.112 is gonna be here. So this dot is gonna be here. You understand? So this dot is in my.
I don't know. I just so this value, because you Q to get the Q2, right?
Yes.
The Q2 is based on this date, but this value is on this date.
If it's inside the range, so
your Q2 is include this value.
If it's inside here. If it's not inside, if it's outside, if it's like here.
Yes.
So it does not include Q2.
If the value in the range, so your Q2 is include this date.
This point included in my Q2. Yes. But very good. Nice. So this is Daijubu. We move forward. We go move forward. Now this is for a medical physicist or for a physicist in general, is a very big topic. And if I explain this one, we will never finish. It's an endless topic. Very important topic. It's called the probability. Yeah? I am not gonna explain it. It is.
Can you move focus?
Tell me, okay, so this probability, I am not gonna explain all details. For a physicist, it's an endless topic. Very beautiful, very amazing, but it will take too much time.
Yeah.
And it is not easy. Not everyone can catch up easily. However, we will talk about what matter most. So what matter for us most is that probability measurement, which means how likely this event will occur. We can estimate how likely these things will happen. And probability, basically, it is 0 to 1. 0 is impossible, it will never happen, it cannot happen. 1, it can happen. Now, I'm not going to go to too much details. I just want to share with you that for us in probability, we have two types of probabilities, are the main. One is the theoretical probability, which we can do it in mathematics and physics, theory. And the other is experimental probability. That's what we all use in our research, because we all do some kind of experiment. And then in my experimental probabilities, and for example, we do the detector measurement, biological experiment, or clinical trial, it doesn't matter. But we all use this one. We have to find out our probability distribution. And then in this probability distribution, there are too many types of different probability distribution. There is normal probability distribution, cumulative probability distribution, exponential probability distribution. But mostly we do normal probability distribution. However, in my probability distribution, for me to find this probability distribution, we use two main equations. One is called a probability mass function, which is this one. Second one, it's the probability density function. the most important one for us. This one. I move forward. I go next. Why is not going next? Now, my next topic is probability distribution. Too many parts. This is the most important thing. Now, this fx here, which means the function here, it is always continuous normal distribution. This fx, it is this function, which is equal to 1 divided by the standard deviation, the square root of 2 pi exponential to the variance. If you remember, this one is the variance, where we can find the mean. X minus the mean divided by the standard deviation squared. So this is the fx. Now, why does this matter? Because this can tell me how data are behaving inside this. Now, the distribution, it's mean, we call it normal distribution or Gaussian distribution. It's exactly the same. The different is we are just converting the average one standard deviation away, two standard deviation away. We change this value to make them 0, 1, 2, 3, 4, minus 1. So 1 here means I am 1 standard deviation away. Minus 2 here means I am 2 standard deviation away. Now, why we do these things? That's because my standard deviation is not showing me number. My standard deviation is just telling me how far I am in this graph. But now I am interested in a specific area, specific number, specific values. So I have to try to convert this to what we call it z-score. This is my z-score range. Now, the z-score range, also we don't do this, no one does. Excel will do everything to you, or technology will do everything to you. But the z-score is a z-score table. Can you see table here? So if I find my z-score, I find this value, my z-score. If I find it out, then I find my number. Let's say, for example, I want to know how far away I am in this point. So I find this value, which is correlated to 1 standard deviation away. So it's going to be, for example, let's say 1.5. When I find out it is 1.5, I put in the equation, I solve the problem in the equation, yeah? After solving, the value will appear 1.5 or 1.3, let's say 1.3 here. So when I see 1.3 here, I go to the Z table, or Excel go, not me. They go to the Z table, 1.3. Where is 1.3? This is 1.3. For my value, it's this one, 0.017. I cannot even see it, yeah? So this value here, it means I am here. It means the probabilities for my value to be inside this area will stop at my Z score. After this, my value will never go. Understand? I move forward. Now, all this, until now, this is for us to analyze our data, to see, absorb our data. Now, 7, 8, 9, 10, it's another story. It is not we are predicting. We want to see how our data will behave. What can they tell me? What can I tell them? So this, they call it inferential statistics. It starts with two things: estimation and prediction. So now first I estimate things. In my research, I am estimating if I do this, this will happen. If I don't do this, this will not happen. And according to my data set, I can find how you could. I can find how likely this will happen and how likely this will not happen by my estimating according to my data. And the other important one is the prediction, which means my hypothesis testing. And now I will be talking more about the predictions. Estimation is very important, but we use estimation too. But I think now, for the sake of time, I will just go with the hypothesis testing. Yeah. So, and this is what allow me to predict. And the important things is that the hypothesis testings is always two tests. One is, we call it the null hypothesis, which is H naught, and the alternative hypothesis. What we do in the hypothesis testing, that I state a hypothesis, I say something, and I need to provide an evidence from my data to see my hypotheses are acceptable or not acceptable. So I have to analyze my data, and I have to see the result of my experiment and look at it, and to see this result agree with my data or did not agree with my data according to my hypothesis. Usually in the academic scientific world, we always have first the null hypothesis, which means nothing will change, no effect, it's normal. I do my experiment, and the result I see, I am expecting no change at all. Any change will happen, it means that it happens randomly. The other alternative hypothesis is that the result of my experiment will be different than the result predicted. And for me, and not just for me, it's all scientists' world. We have to have our hypothesis, and then we try to find out, can we reach the result of this hypothesis if it goes according to what we accept or what we don't. So in the scientific language, we say this hypothesis is rejected. If my null hypothesis is rejected, automatically it means the alternative hypothesis is, we fail to reject the alternative hypothesis. If I fail to reject the null hypothesis, it means automatically I am rejecting the alternative hypothesis. So let's go. If I say the result show no effect, I have hypothesis. Results show no effect. So I fail to reject my null hypothesis, which means automatically I reject my alternative hypothesis. If I say the result of my experiment show different, it means that I reject the null hypothesis, which means automatically I will fail to reject alternative hypothesis. And we do this, there are too many different tests, too many testing tools to provide this, if we accept or we reject. But I'm not gonna be talking too much. I just want to mention it quickly now because of time. So for us, when we have, there is this amazing test. We can talk and discuss later about it more if you want. But for us, and for this chi-square test, I used, and this test helped me prove or disprove my hypothesis. So the test is basically, I have my null hypothesis. I need to find this equations, which gonna make me prove that my hypothesis is right or my hypothesis is wrong. Then I can defend this one in my thesis. Yeah. So what does this mean? What does this mean is that it means I have data, and this data set allow me to, what happened? This data set allow me to reject my hypothesis or fail to reject my hypothesis. And my laptop is dead maybe. Anyway. So if this value is here, I have my curve. I don't care. I will do it quickly. Because B value is very important. But this is one is dead. Okay, fine.
And jump to the earlier.
My laptop is sick. This is B value. Anyway, it will take 5 minutes. I don't need this.
Oh.
So this my test, yeah?